Welcome back again. I hope you have stretched out a little bit and pick a comfortable place to continue these sessions. My name is Henry Wu, and I'm a customer engineer for Google Cloud. In this module, I'm going to talk about storage and monitoring. At any point during the session, if you have any questions or comments, please feel free to leave it on our platform. We have a team standing by to answer those questions for you. This module is going to be a little bit technical, but trust me, it's going to be fun. Let's get started. There are 3 topics I'm going to cover in this module. The first topic is about storage bucket operations. The second topic is about application monitoring. And finally, we're going to talk about authorization and authentication. So to use Google Cloud Storage effectively, let's take a look at some concept where it is built. First, project. What is a project? It is where all data in your cloud storage belongs to. And it consists a set of users, a set of API, a billing accounts, and also monitoring and authentication mechanism in here. You can have one or multiple projects in one account. Second is buckets. Bucket is the basic container that holds your data. You can use buckets to organize and give control access to your data. When you create a bucket, you should specify a globally unique name and also the location where you need to put it, and finally, the storage classes. Finally, it's an object. Objects are the individual piece of data that you store in Google Cloud Storage. There's no limit of number of objects you can put into one bucket, but there is a size limit around 5 terabytes for a single file. If you are dealing with really important files, you might want to keep everything you do in the history. So you want to keep every modification in the buckets. And in Google Cloud Storage, you can do that as well. So let's say, by default, the Google versioning is disabled. So when there is a new object writing into your bucket, you will delete the older version and replace it with a new one. If you enable the object versioning function in your buckets, then both versions will remain in your buckets. Next, let's take a look at some classes for Google Cloud Storage. There are 4 classes available to you, depends on different use cases, availability, and also the API that it allows you to do. First is standard. It is the most commonly used case. It's used to serve those frequently accessed data, such as web content or streaming video, etc. On the other hand, we have nearline storage. This is a low-cost, highly durable storage for you. And it's very ideal if you are dealing with data that you only plan to read or modify on average once per month. For example, if you want to continuously adding file into a bucket, but only want to read or modify once per month for analytics purpose, then nearline storage is a great choice for you. Cold line is very similar to nearline. It's also a very low cost, highly durable storage service, but the difference between cold line and nearline is the minimum storage duration. Cold line has a 90 days of minimum storage duration, so if you are planning to access your data once a quarter, this is ideal for you. Finally, we have archive. If you are planning to keep all your data entirely for backup and archiving purposes, then archive storage class is ideal for you because this is the most cost-effective option, and also you can serve as highly availability for you. Because nearline, cold line, and archive are designed to store those infrequently accessed data. So there are charges for you if you are retrieving those data or metadata for these classes. So next, I'm going to talk about operations. There are two types of operation. One is strongly consistent operation. The other is eventually consistent operations. What does a strongly consistent operation mean? Strongly consistent operation means that when you perform operation in Google Cloud Storage and you receive a success response, the object is immediately available for you to download or doing some metadata operations. These are the operations that are strongly consistent, which are read after write, read after metadata update, read after delete, bucket listing, object listing, and finally granting access to resources. The other type of operation are eventually consistent. Those are revoking access from objects or accessing public readable cache objects. The reason why they are eventually consistent because they might take up to the minutes for the change to take effect. And so the operation won't be consistent until those actions has taken place. So we finished talking about operation and some storage classes. Let's talk about how can you get your data back. There are 4 options for you, depends on your use case. The first option is through the typical API request. From this type of endpoint, we have 2 options. The first is you through the XML APIs, and you can query your data back by the following URLs provided below. And also we have the JSON options. You can use the URL provided here also. And these type of API requests will be able to serve by HTTP and HTTP requests, HTTPS requests. But if you are authenticated to Google Cloud Storage API using OAuth 2.0, then you should consider using HTTPS. The second option, we call it CNAME redirect. CNAME redirect is a special DNS request that let you use a URL from your own domain to access a resource. For example, let's say your domain is example.com and you're selling travel maps and you want to publicly open this travel map to the world. In this case, you can create a bucket in a cloud storage and then create a CNAME records in DNS and redirect the request from travel-maps.example.com to the cloud storage URL where the bucket is located. So your public can access those data from there. The third option is authenticated browser downloads. If you are signed in to a Google account and have been granted a permission to read those data, authenticated browser download is very useful for you because it uses the cookie-based Google control authentication in conjunction with the Google access control list to let you download the data. You can get your data by using the following URL, which is storage.cloud.google.com/your bucket/the object. And for this endpoint, only HTTPS is available. Finally, we have content-based load balancing. If you create a bucket and you have a backend behind your load balancer, you can assign those backend to a cloud storage and modify the web-map URL. So the request can be routed to the URL maps that begin with the /static path. So for those traffic goes to that path, we'll send it to a storage bucket, whereas other requests will still be sent to the virtual machine instant group. When you consider picking your location, you should consider picking by following those regional specific compliance requirements. And if you are doing analytics, it probably makes sense for you to put your data in the regional buckets that are near to you, so it can improve the performance and then reduce the network latency. Finally, let's take a look at how you can control the access to your Google Cloud Storage bucket and object. There are 5 ways to do so. First, you can use Cloud IAM. Cloud IAM stands for Identity and Access Management. Using Cloud IAM will allow you to provide a permission to a bucket and also all the objects inside this bucket. Give you the ability to provide a bulk access to a bucket. But it does not give you the fine-grained control over individual objects. If you want to do so, then you should consider using our second option, which is called Access Control List, ACL. However, it is only recommended if you really need the fine-grained control for individual objects. Because if you apply ACL to all the objects, sometimes it will become a little bit messy and difficult to manage. And actually, IAM already allows the permission to be granted inherently. So if you have bulk control, you can use IAM. You need more fine-grained control than using ACL. The third option here is called signed URL. This allows you to generate a time-limited read or write access to an object through a URL that you generated. You can create a signed URL using gsutil command or programmatically in your application. The fourth option is called signed policy documents. If you're using HTML form posts to upload your objects, then you should consider using signed policy document because it allows you to specify what can be uploaded to the buckets. You can allow greater control of the size, content type, and ACLs for those objects. Finally, we're talking about Firebase again. It gives you the granular and attribute-based access for those mobile and web applications, including all the storage database in Firebase. So that's a great tool for you if you are a mobile developer. So let's take a look at what it looks like in the Google Cloud Storage. I'll give you a little demo here. So first, let's jump into our Google Cloud Console. So as you can see, here in the screen, you can see this is a bucket I created for this demo purpose. We call it COB-buckets. So the first thing I'm going to do, I'm going to jump over to my command line here. And I'm actually creating a text file here. So let's see. I'm going to retrieve this text file. And it says, hello, Cloud OnBoard in this file. So the first option I'm going to do is I'm going to enable my object versioning. So I'll just set versioning, gsutil versioning, set on, and then give the URL of my object. In this case, it is cob.buckets. All right, so let's say the process is going on and it's already being enabled. So next thing I'm going to do is I'm going to upload this image to my Google Cloud buckets. So how do I do it? I can just simply use my very familiar Linux command here, like copy. So I'm using gsutil copy and copy my text file here to my bucket. So as you can see, the command is actually pretty straightforward. So I'm just typing right in, and boom. You can see, so here now you can see the text file already uploaded to my bucket. So if I jump back to my bucket and I hit refresh, you'll be able to see there is my text file over here. And of course, you can absolutely using command line to do so. Let's say if I want to list it down to see what's inside my bucket, I can also do that by typing list command. So this gives you the name, and also followed by it is the version of this object. So the next thing I'm going to do is I'm going to try to modify this object and upload again to see if my modification is kept in this bucket. So I'm going to modify this file. And let's say I'm giving a version 2. I'm adding a version 2 line here, and then save this file. I'm going to run the same console command again to copy it into my same bucket that you see here. If I go back to the bucket, you can see it still shows one object here. But if I run the list command again, so you can see there are 2 versions, see right here. And in the gsutil command, as I mentioned before, I can use my very familiar cat command to see what is inside this file. So if I go to the first one, then this is my first version. If I go to the second one, I can see there is cats. This is my version 2. So pretty clear, right? So it keeps, if you enable the versioning, it will keep every modification that you do in this bucket. So the final thing I'm gonna do, since I want to share this file to my friends and wanted to download it for me to take a look, so I'm gonna create a signed URL here. And I'm giving a 10 minutes time for my friend to be able to see this file. So here I'm typing the comments. I'm specifying the buckets and the object. Cool. So as you can see here, I already got my signed URL back. I'm just copy and then open the new tab. And let's take a look at what it looks like in this URL. Boom. So as you can see, if I zoom in a little bit, it shows Hello Cloud OnBoard version 2. Right? So it's pretty easy for you to, if you want to modify your data, you want to enable the versioning, and also the command line is just so easy for you to deal with your object data. So the next section, I'm going to talk about debugging and monitoring. So when we talk about debugging, there are actually a very powerful tool in Google Cloud. It's called Stackdriver. Stackdriver is a solution for you to help you to enable the debugging, monitoring, and diagnosis of your application that runs on Google Cloud Platform and also AWS. So it's a multi-cloud service available to you. There are 6, they're comprised of the 6 features. We have error reporting, debugger, logging, monitoring, trace, and profiler. The amazing thing is these diagnostics features are actually well integrated to each other. So it helps you connecting the dots when you're trying to diagnose your applications. So just quickly use this beautiful slide to summarize how good Stackdriver is. It actually increases the reliability by giving the user the ability to monitor GCP, AWS, and multi-cloud environments. And it helps you to identify the trends to prevent issues from happening again. And finally, because the great UI, the great analytics tool, it reduces the monitoring overhead and raise a noise to fix your problem. So it's a pretty amazing tool. So next, I'm going to dig a little bit deeper of what it looks like by using Stackdriver. So first, we talk about debugging. So let's say our application has error in our application. And I want to use Stackdriver error reporting and debugger to debug this. So this is what you see if your error occurs in your system. So Stackdriver error reporting will collect those errors and give you the summary of the occurrence of how many times this error happened. And if you click into this arrow, it actually take you to the line where the error really happens. So show you the problem so you can deal with it later on faster. And of course, we also have a debugger that already in place for you. This debugger actually can give you the ability to hit the line of the code where the error happened. And then it's not only take you to the line, but also debugger create a snapshot of light line for you. So the snapshot actually include the value of the local variables. So if you are a developer, you know what's going on in your application by seeing those values easily. Of course, you can manually select other lines and then rerun it again, so it will be showing to other value as well. The amazing thing is you do not need to restart your application. So it's all built in. And it's all built in, and you can inject your log information without interfering your application, even it's an application on production environments. So next, I'm going to talk about logging. So logs really gives you a sense of what's happening in your application. And in Stackdriver, you can install Stackdriver logging agents into the instance that you want to diagnose. So here you can install a agent. This agent is built based on the FluentD technology. And you can write your log in those versions, and you can write your log of your existing log files, such as syslog, and those agents will collect those syslog files from you and then send it to a Stackdriver for further analysis. And there are also some compute environments that already have the logging pre-configured. These environments are Cloud Data Flow, Cloud Function, and App Engine. Of course, if you are using Kubernetes, you can also do that by simply clicking and enable it in the console. Let's talk a little bit more about logging and monitoring. You should consider setting a log-based metrics and setting alerts when something happens in your applications. So in this case, you can see there is a log for a specific request, and if it expands out, you can see there is a success request. And later on, if you do some action about this log, you can create a log-based metrics and setting alerts for those kind of metrics. So I'm just quickly show you what it look like in Stackdriver logging viewers. So I'm gonna switch back to my demo environment again. So here, as you can see, this is a app engine that I created for this demo purpose. This is a simple guestbook application. I'm just click here. And yeah, so this is what it look like. So basically, it is an app engine, and you can leave whatever message you like say Stackdriver, for example. Cool. I'm just signing, and it will just show here. So the next thing I'm going to do is I'm going to take you to what it looks like in the code, in the logs. So if you in the Google Cloud Console, you can navigate to the logging parts. So here, you can see all the logs in this area. I'm going to just zoom out a little bit. Yes, you can see more logs now. So here you can get some filters, such as if you want to filter to specific GAE application, filter to specific application, you can do that. So here it is the request I just made. So you can see this is the request. If I go down into it, if I click into this second here, it can actually take me to another diagnostic tool, which is trace Stackdriver traced. So this trace list will show you, okay, how much time does it take to finish this request, and then what are the steps that it did there in this request. For example, you have like query some data from the data store and then retrieve it back, for example. So in this log, this collects everything in this view, but sometimes you will lose track if you didn't properly manage it. So next thing I'm going to show you is to create a log-based matrix. So we have some system metric here already built in, and here I'm just to use some user-defined metrics. I've already created one. I called it food count. So basically, I counted every matrix that followed by a food path. So if I query food and equals to whatever food, and you will be kept in these logs. So you can create whatever you like based on the path, based on the strategy you want to monitor your application. So if I have this in place, Next thing I'm going to do is I'm going to set up an alert. And these alerts can be based on the metrics that I just set. So in example, I'm going to create an alert, COB, for example, and add a condition. So this condition could be like, if I'm going to targeting a GAE application, and I'm going to click the metrics. As you can see here, this is actually the metrics I created for this demo purpose. So I'm just click here. And at the bottom, you can see we can set some threshold. So in this case, I'm going to set whenever there is a request that hit these metrics, I will be trigger this alert. So I'm going to click add. And then here, the next part, most important part is notification. So you want to know how do you want to be notified, right? So here you can actually select different channels. You can use emails, Slack, SMS, or using the simple webhook or PubSock. In this case, I'm going to create an email and queuing my demo email here, and I click add. So to configure those channels, you can click here to have more configuration. Just click save. So because I've already created an alert before, so let's say if I refresh this page, I'm supposed to get notification, right? So if I switch back to my other platform here and I click refresh, yeah, boom, you can see this is the notification it just sent to me at 12:24 just now. So you can see this is the alerts. It's the name and it's a condition. In this case, it is a food counts metric that I just set. Pretty amazing, huh? So by now, you should see a pop-up window on the right side of this platform. Make sure you take some time to fill it out. We will discuss it at the end of this module. Thank you. So next, I'm talking about some performing and tuning performance best practices. So let's say you have all the metrics in place and you start monitoring your application. What should you consider to do next? You should consider, there are some questions that you should ask yourself. For example, you might be, how fast is the database growing? How many users have I added in the last quarter, for example? Make sure you analyze the trend. You know what's going on in your application. Second is compare. You should compare your result over time or between experimental configuration. So the example question could be, is the site slower than it was last time? Are requests served faster with Apache than Nginx, etc.? You should always compare experimental configurations. Next one is alerts. As I just shared with you, you should have alert system in place. So whenever there is something that's about to be broken, you should address them quickly. If there is already broken, then you should fix them immediately, etc. Try to perform an ad hoc retrospective. Not just do it at the end of every sprint. You can do it in an ad hoc way. For example, if the latency starts to spike yesterday, for example, you should have a retrospective again to see what's really happened around that time. Identify which API resource you want to monitor. So, it could be some compute instance. You can be the network layer that it involves. Just think about your user journey. What does it look like? How does your user interact with your application? Then you'll find out more about how you want to monitor your resource. Next, you should always follow the SRE best practice. SRE stands for Site Reliability Engineering. So two best practice here is you should set up a service level indicator. We call it SLI. This could be something like latency or average page load time. When you have that in place, then you should consider setting an SLO, which is service level objective. So this could be a target value or a range of value for your services. For example, you can set a SLO look like this. You want to see like 99% 99.9% of the requests over the last 30 days have latency less than 100 milliseconds, for example. So there are four golden signals. The final step, I would say, is you build a dashboard, because the dashboard can really show you what's really happened immediately about your application. And when you create a dashboard, you should consider these four golden rules. First is latency. You should have the latency in place in your dashboard. A latency is the amount of time it takes to serve a request. And when you taking latency in consideration, make sure you separate successful and unsuccessful ones. Because some unsuccessful requests might be returned, might be served very quickly because of the loss of connection to a database. So it might be misleading if you're still including those unsuccessful requests to your dashboards. The second is traffic. Traffic is measured by how much demand is on your system. That could be a number of HTTPS requests per second, or if you're measuring the database, that could be like numbers of read-write operation per second. The third is about error. Error is the number of failed requests. So it could be like HTTP 500 requests, a response, or could be HTTP 200 response, but with incorrect content. Finally, we have saturation. Saturation means how full your application is and what resources are being stretched and reaching the target capacity. So make sure you have all that in mind and have dashboard in place, then it will help you to monitor your application better. So next, I'm going to talk about how you troubleshoot your performance. Let's take a look at this chart first. So I'm just take a drink of water first. As you can see, what does it look like to me, to you? To me, it looks like a Tai Chi circle. It's a harmony, you know. Development and production is always like a harmony. You do something in the development and you ship it into production. And where there is something you need to change in production, you ship it back in development. And the cycle continues. When you are in your development environment, there are three things that you should consider. First, you should add a performance test to your applications. These tests will ensure your performance that will not degrade when you're trying to fix bugs or adding new features or changing the software. And you know, when doing these performance tests, will also help you detect and address those issues early in the development phase. The second point is that you should consider adding those performance watch points. So these watch points are, first is web authoring. What does it mean? It's that you should always review and design your implementation of your web page and to use some tools such as page speed to check those lack of caching headers, lack of compression, too many HTTP requests, etc. Second is about boot time. You should consider evaluating those code boot time performance as a watch point. This code boot time will ensure your code your new instance to be spin up when you really need it and in a high performance way. To optimize the process, you should ensure that your code only refers to those external libraries when it's really needed, and to remove those unnecessary paths to increase your code boot performance. Finally, we should look at self-inflicted load. So that is something like your service to service code, or too many AJAX requests. So these will help you to eliminate those unnecessary processes that will cause the potential performance issues. The final suggestion here in development phase, there are 6 things here, is you should always check those application errors. Whenever there is an error, no matter it is a 400 or 500 error, you should identify the root cause of the log message to really dig down into what's really happening. Second is runtime. you should consider using the runtime or just-in-time code generation to increase the performance. Third one is about static resource. You should put your static resource to something like a CDN and put it into the bucket. The fourth one is about caching. So caching, you should consider putting those frequently accessed values to those caching service, so you don't need to retrieve again from the server or from the database. The fifth one is you should consider building the one at a time retrieval. If you have so many requests that happens in serial, you should consider replace those individual requests with the single batch. It can help you improve your performance. Finally, is error handling. As I said before, you should consider implementing a retry with exponential backup way so that your resources won't be exhausted by retrying those errors again and again. In the production environment, there are also two things I want to suggest here. So first, you should also implement some watch points. Some of the good watch points for production environments are, first, is your user load. You should be able to know and analyze the most frequently requests and the solely requests of your application. And you should confirm that those requests are expected. And when you really confirm those, you should deep down into what the cause of those slowest requests and solve those questions. The second is to look at the periodic load. Make sure every load, any surge in your load should be in relation to a business reason. For example, if you are having a big sale, if you are promoting your product, etc., you should make sure that each load should make sense and align to your business reasons. Finally, it's a malicious load. So confirm that all load is expected and legitimate. If you are a web or mobile client, that your most traffic will probably come from the mobile web clients, not by IoT devices, for example. And you should always be able to segment those users and to understand where the majority requests come from, and probably consider moving your application to those regions. The second suggestion here is you should always review your deployment settings. You should consider to have auto scaling in place and set up a load balancing for you, because it helps you the ability to adapt to those traffic volumes. And then you should set a target utilization of your instance conservatively. So if there's a new instance coming up, you will make sure that your application will be still up and running. Second is region. So as I said, you should identify where the bulk of your traffic is coming from, and you move your application to those regions to reduce the latency. Final suggestion is cron job. If you have so many repetitive and scheduled jobs, you make sure you do some feature such as cron job to do that faster, easier. So the final section of this module is authentication and authorization. So in Google Cloud, the way we do authentication and authorization is all enabled by IAM. IAM stands for Identity and Access Management. So the idea here is pretty simple. So actually, you identify who has access of what for which resources. Who stands for a member and has what access is a role and for which resource you want to give to the user. And you should always implement the security best practice, which is giving out these privilege of permission that is only needed for that role to do their job. So talking about who, what are the members of IAM? Who could be the member of IAM? There are 5 members here. The first is Google Cloud account. So this could be a developer, an administrator, a person. Basically, it is a person who has an email address, who has the Gmail address, will have an address associated with the Google accounts. That's the first member. The second member is a service account. It belongs to a machine. It is an account for a machine. It could be belongs to an application or instance, etc. Instead of giving an individual. The third one is Google Group. So Google Group is a collection of Google accounts and the service accounts. It's very useful if you want to organize your permission and giving out. It's a convenient way to apply those access policy to a single group. But however, group accounts does not have the login credentials. So you cannot just use these group accounts to directly access your request. The fourth option is G Suite domain. So if you already use G Suite, amazing. You probably already set up all the organization unit, all the group, and the member in place. And you can just use those group and member directly in your IAM to use it in the Google Cloud Platform as well. So the final member is Cloud Identity Domains. Cloud Identity Domains represent a virtual group of members. It's very similar to G Suite domain, but it just doesn't have the asset of a G Suite application and features. Let's talk about what resource can the members have access to. So it's basically, it's everything in a Google project, Google Cloud project. It could be the project, it could be the compute instance, it could be a cloud storage bucket, or PubSub topic, whatever you want to get access to. Next, I'm going to talk about what operation can you do in IAM. So in IAM, when you are granting a permission to a member, the syntax looks like this. So it starts with service.resource.verb. So if you want to, like for example, if I'm a user and I want to consume the subscription from the PubSub, then your syntax would be look like PubSub.subscription.consume example. Next, we're talking about roles. So the role is a collection of permissions. You cannot assign a permission to a user directly. Instead, you should grant them to a role first, and then assign those roles to a user, right? So there are three types of IAM roles. First is primitive, and the second is predefined, and also custom. Depends on your needs. You can customize your permission that you like to grant to a user. First, let's look at the primitive roles. There are three types of primitive roles here. And the primitive roles apply to a project and all its resources underneath this project. There are three roles. The first is viewer. Viewer simply is just only has a read-only actions. Can only read the resource that it has. Editor has everything the viewer has, plus the action to modify the state. And finally, we have owner. Basically, you own the resource, so you have every permission it has. You can grant other people access. You can set up billing account for a project example. The second type of role is predefined role. Predefined role gives you the granular access to specific Google Cloud resources. It could be different, depends on what resources you want to grant it to. For example, if you want to grant a big table admin to a user, you can do that. If you want to grant a big table user or reader, there are different roles, depends on what role you are, depends on which type of resource that you are targeting to. And finally, we have the custom roles. So custom roles let you have the ability to define your own permissions. So let's say if there is a member in my, there is a team in my company, and I only allow them to operate my EVM instance. For example, I only allow them to start and stop the VM, but not allowing them to modify the configuration of those VMs. In this case, you probably can consider using a custom role. So you can give them the VM get list and start-stop permission to that specific role, and then assign those roles to a group or a specific member. Sometimes, if you have so many people controlling the permission, it will get a lot messy or become difficult to control. So in this case, you can consider using policy. So IAM actually have a policy in place that to let you to enforce those access control to those resources that you assign it to. This is what a policy looks like. It consists a list of bindings. Binding has a list of member and the roles. So for example, if you have a member here and you want to, for example, it's alice@simple.com, it belongs to this group, and you can assign them to a role like owner role, for example. So you have a role, you have a member here, whatever member you want to put into the policy binding. And these binding, and one policy consists of many bindings, and you can assign those policy into a resource that you want to assign to. So just reminder a little bit, the Q&A pop-up will be disappear shortly. So if you haven't finished them, please enter them now. Thank you. So next, I'm going to talk about service accounts. So as I said, service account belongs to application or a VM instead of individual. They are used for your application to call those Google APIs or services so that the user don't need to involve in the authentication process directly. So, and service account, you can think of it as a member, but it just don't need you to control it, don't need to authenticate manually. But how does it work? It works by giving out the keys. So you can generate a pair of keys, and you can have up to 10 pairs of keys associated with this service account. And to increase the security, you can also facilitate key rotation. You can choose those security to be managed by Google, or you can choose to done it by yourself manually. So when you have those keys in place, you can use those keys to enable the authentication authorization when you have the access to the resource that you're trying to access to. Of course, as I said, you can use your external keys. So the key not necessarily need to be managed by Google. You can use your own key, but just to make sure, just to remind that you should always implementing those security best practices as well. And those keys that you use in Google Cloud Platform, you cannot use it out in other places in your own environment. Of course, you can assign many service account in one project. Let's say you have multiple application, multiple service, and you can have more fine-grained control for each of them by giving them separate service accounts, and to give those service account the permission that they need. These are the steps you should consider when these are the steps it takes for you to authenticate your application using a service account. So the first is that obviously you need to create a service account first, right? So the first is you create a service account on the console. So once you create it, it has a view for you to take a look at what are the keys available there. And then second, in your application, in the instance, you can generate and download your credential file. That could be a private key. You could download it into your instance. And the third step is that once you have that in place and you have the service key you need, then you can set environmental variables that pointing directly to the file that those service account key located. In Linux and OS, you can export those environmental variables such as Google underscore application underscore credential to point to the file. At Windows, you can also set the same configuration using the same similar approach. So once you get them all set, the final step for you is you can start authenticating your application. So here you can see there's a simple Python code. It tries to connect to a cloud storage, and it's, as you can see here, I didn't construct any of the authorization or authentication method here. I just construct a client, and the client will automatically look into those environmental variables to find the key that is needed for the process to operate. We call the process application default credentials. These process, again, first, there are 3 steps for the application to be authenticated. First, the application will check the Google_application_credential environment variable. If there is any file path that's specified there, you will go and take a look at those key files and use it to authenticate. If it's not, you will then look at the default service account that you set in your project. Finally, if 1 or 2 are not found, then the error will be thrown in your applications. So this concludes my presentation of my second module. I would just like to give a blessing to all of you who joined this session today. May your query flow and may the pager stay silent. Let's take a look at some questions that you already answered previously. I have 2 questions I prepared previously, and let's take a look at this. So the first question I have is so if your user are encountering error in your application and you want to view the stack trace to determine where the error occurred, what service should you use and to help you solve the error? So I have pretty average response. The answer is error reporting. Just as I shared in the previous slide, you can see Stackdriver error reporting actually will accumulate those occurrences of the errors and to see how many times has happened. And if you want to dig deeper into it, you can click on those arrows and you will take to the stack trace to see which line is it open. And of course, as I said, you can set up different debugger breakpoint to those lines, and you can have the variable values available for you. So the next question is, let's say if you want to do streaming, you want to stream logs into a Stackdriver logging from a third-party application running on compute engine, what service should you consider? Pretty amazing. We have 54% of people answering right. So you guys are super amazing. This is correct. In this case, as I said before, Stackdriver logging allows you to download the logging agents directly to your instance that you run your application, so that it will collect those logs and send it back to Stackdriver automatically for you. So that's the end of this module. We have the final module, module 3, coming up really shortly. So please stay tuned, and we will have a short break, and I will see you soon. Thank you.